No, this is a thing. A ring of mass and radius r is given linear velocity and counterclockwise spin. Counterclockwise spin. Clockwise, counterclockwise spin. Omega naught. Or let it be this one here. Counterclockwise spin and release on rough surface at equal 0. Find the time taken by it to attain pure rolling in following cases. It's a ring of mass and radius r. V naught is given, and numerically what happened? V naught equal to r omega naught. This is, I think, very important. There's a point of contact. Okay, let's study how it is counterclockwise. How do we do this counterclockwise? I think you might have seen, no? You might have taken some ball or say some like a football. When you kick it, no, what happens? It'll go and returns back, no? Or in billiards game, or you can take bangle, especially you keep it on table and press it, no? So what it will do? The bangle, it will spin like this, and it will return back, no? That is what I'm trying to discuss here. It is given negative spin, counterclockwise spin, and linear velocity like this. Now let's come for directly the velocity of point P. What will happen? We'll take velocity of point P. Velocity of point P we'll calculate here. So shall we equal to V naught plus R? Both are acting towards right. So then now the friction should act towards left. This friction acting, what it does? It will set up a torque about center of mass, and it will retard the motion of center of mass. Then what will happen? The linear velocity decreases because friction will act opposite to linear velocity decreases. This friction will set up a torque. Angular velocity also decreases. Both will decrease here. And finally, what will happen? Will attain pure rolling is what I'm trying to make a guess. So let's calculate the initial angular momentum. Let's begin with initial angular momentum. LPZI. Initial LPZI. What is this angular momentum due to translatory motion and angular momentum due to rotating motion about center of mass? No, angular momentum of what? Angular momentum of translative motion. Different at different times I'm writing in different ways so that different books open, they're given different notations like this. Angular momentum due to translatory motion of center of mass plus angular momentum due to rotating motion about center of mass. No, angular momentum due to translating motion of center of mass. MV naught R clockwise. Due to rotating motion, IC omega naught. What about this? Anti-clockwise. This, let me take it positive. Anything you can, let me take this is positive. This will be negative. MR square. Moment of inertia of this, of the ring. It's a ring, no? Ring is how much MR square? What is numerically? Numerical, we know that. So if I substitute that, so I'm getting angular momentum 0. So what do you mean that finally the angular momentum should be 0? Finally the angular momentum should be 0 means what will happen to the ring? The ring will just come to rest. So how do you can say? Because initial angular momentum is 0. The ring will finally comes to rest here. Sir, are you sure? Yes, the initial angular momentum is what? Something which will help us a lot. Now you can see finally this will be, I'll give supportive diagrams, two diagrams I'll give, so that will be easy for you. This is radius R, this is center of mass. This friction will decrease velocity of center of mass. It will also decrease angular velocity. When I go and check it, still the velocity of point will be towards left and there is a friction. And it has finally come to rest. Sir, why don't it have some angular velocity or linear velocity? The total angular momentum should be 0, no? Why don't it should have some decrease omega in V? No, finally the friction what happen will be acting. And it will see that the velocity of center of mass and angular velocity both will become 0. So what is this slipping you should call? Backward slipping or forward slipping? It's a forward slipping, no? It will come to rest here. This will trouble you. So this condition is very important. Almost in SEORM also is explained everywhere. So you wrote V naught equal to R omega. It should be pure rolling. Where is the pure rolling? It's a negative spin, no? What is the velocity of point P? If the velocity of point P is 0, then it will be a pure rolling. Velocity of point P, in fact, non-zero here. Check it. Please do notice such small things here. Now, next again, the same problem. The center of mass is given velocity 2v naught. Let's check again according to the given condition. It should be 2v naught plus r omega naught. So what is the direction of friction? Will be towards left. Now this friction, what it does,